Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments, where tonight we're going to use a little geometry and some TI technology to get you ready to go with your students. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough to teach, tough to learn concepts accessible to all my students. And joining us tonight is Karen Camp and Steve Phelps. Karen was instructor of math education at Yale University for 15 years and previously taught high school and middle school mathematics in Connecticut and Pennsylvania. She's been a T-Cube national instructor since 1998, providing professional development at conferences, workshops, and webinars. Karen is passionate about using technology effectively to enhance student understanding in mathematics. Karen, we're excited to have you with us tonight.
Glad to be here, Mike.
And Steve, a longtime geometry, statistics, and computer science teacher, is currently a math and computer science teacher and a math and instructional technology coach for Marymount Schools in Cincinnati. Steve is also a TCube National Instructor as well and co-author of Advanced Quantitative Reasoning Mathematics for the World Around Us, and most recently, Demana Waits AP Pre-Calculus. So Steve, congratulations on that most recent publication, and it's great to have you with us as well.
Hey everyone, thanks, Mike.
All right, Karen, will you discuss our agenda for tonight?
Tonight we're going to go over some dynamic geometry tools in Cabri Jr. on the TI-84 family and TI-Nspire environments. We're going to look at some trapezoid constructions and explorations. We're going to investigate segments in circles and the power of a point. We're going to construct conics from geometry definitions and use lock measurement tool to discover relationships. We're going to share some 3D visualizations and illusions, and finally we'll wrap up with a webinar drawing.
Awesome. Thanks so much, Karen. And Steve, can you talk through our expected outcomes?
I will do that. There are three expected outcomes. After this, you'll be able to use the geometry features of the TI-84 plus CE or the TI-Nspire CX calculators to construct and explore geometric figures. You'll be able to measure, capture, and calculate dimensions of figures to generate conjectures about geometric properties. And the third one is you'll be able to identify ways to utilize geometry and 3D geometry visualizations for algebra, geometry, and pre-calculus classes.
Awesome. Thanks so much, Steve. Tonight we'll be using the chat window to send general messages. So many of you have already started doing that, letting us know where you're joining us from. And I saw we have lots of people from all across the world, which is always really exciting. If you have any questions for Steve or Karen, feel free to use that Q&A window on the right side of your screen. And as a reminder, the session is being recorded, and we'll provide a link, the event certificate of attendance, as well as a link for the documents at the conclusion of the webinar. Karen, it's all yours.
Super. I'm really excited to be here tonight because geometry is one of my favorite things to do in math class. And we're going to take on a little bit of a challenge. I'm going to be showing you some activities on both the 84 CE on Cabri Jr. and on the TI-Nspire, so that hopefully you can see those screens on my screen. They're overlapping a little bit. But the biggest thing I want to impress upon you as you're going is that this is dynamic geometry technology. And what the power is of this technology is that it's dynamic and it's asking you and your students to think of what if questions. What if I pull this vertex here? What happens if I lock this measurement? There's going to be lots of opportunities for you to really capture the power of these dynamic geometry tools. Now, as you're following along at home, urging you to just watch tonight rather than try this on your own device. The whole webinar is recorded and you're going to get all the documents and calculator files that Steve and I are using, so you'll be able to practice it more after the webinar. Okay, so let's begin with a trapezoid exploration. And what I like about this and why I'm sharing this with you tonight is that if any of you are brand new to geometry technology, is I'm going to show you some of the tools that we've got available to do constructions. So first of all, on the TI-80, on the TI-84 calculator, you need to press the apps button, and Cabri Jr. is the second one down. And when you open up Cabri Junior, you have a blank screen. You move around with your arrow keys, and it's going to tell you that we can press the F1, F2, F3, F4, or F5 keys in order to access our menus. And the menus, we're going to begin to construct a trapezoid. I want a segment, and the window button gets me my point and line tools and shapes. So I'm going to begin with a segment, and I have to press enter to start my segment, and I arrow off to the right and enter to end my segment. And you'll notice right away, hopefully, a couple of things about the screen. Over here, we've got a tool icon, which is Cabri Junior's way of communicating to us what tool is active, and you'll see that same kind of tool icon on the TI-Nspire. The other thing is that I'm still in segment creation mode, even though I've created the segment already. And if you can see that endpoint where I've left my cursor, it's flashing. So Cabri Junior is truly a junior program. It doesn't have some of the power of the TI-Nspire, where there are going to be messages that pop up to ask you what you want to do. So that flashing point is asking me, do I want to start a new segment at that point? Is that the thing I want to select? And I don't want to select it. But that flashing is something that you need to pay attention to. And by the way, there are how-to documents in our webinar folder that you're going to get after the webinar. So if you are brand new to this, you can see all of this on some how-to documents. Anyway, I'm done making a segment, so I'm going to press clear. And now hopefully you see that I have a hollow arrow and my point is still flashing, and alpha is the grabber hand. And part of what makes dynamic geometry dynamic is that we can grab and move and see what happens. Anyway, just to continue with my trapezoid construction, what I want to create is I want a point not on the line. So I go back to my window button to get my point tools, and I create a point. And some of you who teach geometry may notice that I am not labeling the points tonight. I find that the labels can be more of a hindrance in some of the calculator-based geometry programs. So I only label points when I must in order to complete the activity and communicate with my students. Okay, so to construct a trapezoid, I'm going to need the construction tools, which are in my zoom button, and I want a parallel tool, and I want to click on the point that is not on the segment and the segment to make a parallel line through that point. To complete my trapezoid, I want to make a new point on this parallel line. And I still have an active parallel tool. I can press the clear button to exit that tool, or just pick a new tool. And this time I want point on. I don't need to select point on if my cursor is pointing to the line, but I'm going to select point on, and there's my new point. And finally, I'm going to finish off my parallelogram using the quadrilateral tool, which requires me to click enter 4 times on 4 vertices. And again, I'm waiting for that little point to flash at me. And there it is. Okay, and on Cabri Junior, the quadrilateral tool exists. I don't have to finish my polygon, which we're going to see us do that on the TI-Nspire in a minute. And the last thing I might want to do to clean this up is I might want to hide that construction line, the parallel line. So I'm just going to hide that parallel line and clear. And before we go any further, what I would do in my classroom is have my students drag and observe this trapezoid. If we pull on certain points, certain things will change. And what I might have my students do is make some measurements to confirm some properties of a trapezoid. And those measuring tools are all in the F5 menu under the or above the graph button. And we can measure distance and length. Area is not so helpful right now, angle and slope. So think for a minute how you might have your students do some measurements to confirm properties of this trapezoid and find anything out. And then of course what you would do is you would drag and observe, see if those ideas that you've discovered hold true for all trapezoids. That's just a thinking exercise. Let's pop over to TI-Nspire. You can construct a trapezoid there as well, just the way we did it. But I want to, over here, construct an isosceles trapezoid to show you one more tool, because an isosceles trapezoid has to have the non-parallel sides equal lengths. They need to be congruent. So I'm going to do the same thing that I started with. TI-Nspire is menu driven, just like the Cabri Junior, but these have a little bit more detail in their menus. I want to point off the line. I want to go to my menu and get a construction tool for my parallel tool. And the same thing I did before, I'm going to click on the point and the segment to create a line parallel. And now the question is, how can I make sure that this distance from my point to this left-hand endpoint is going to be the same on the other side? And for that, we're going to use the construction tool called the compass tool. And it works like a compass. You put your first click on what would be the center of a circle, and your second click out on the other side of that circle, the radius. And so now what I am getting is I am dragging along, as I move my cursor, a distance that is this distance that I'm trying to match. And my third press of the enter button, or a mouse click, is going to be on the other endpoint, and that is going to maintain that distance. Now this line here, this parallel line, I'm going to get my grabber hand, which on TI-Nspire is control click. Whoops, and I did that in the wrong place. And what I want to do is I want to know, where does that parallel line intersect the circle? And so that is going to, I can get my intersection point between the circle and the line. There's actually two spots there. And I'm going to use one of those points with my polygon tool, and that's going to make an isosceles trapezoid. And on TI-Nspire, we have to complete your polygon to click a fifth time where you started. And both of these environments, you can choose a tool and then continue to use it until you're done and you escape or clear out of the tool. On the Nspire, you also have the opportunity of doing a control click or a right click, and that will give you a context menu. So I can choose the hide show tool or just hide these construction items by right clicking on them. Right clicking if you're on a computer, or control menu is going to do it if you're on the calculator. Okay, so now this is oops, let's see what I got here. This is an isosceles trapezoid, and think about what measurements you'd want your students to make to confirm those properties. Now, there's lots more that I would do with kids and spend the time to do the measurements, but I'm going to show you some measurements in a minute. What I'd like to do before we get to measurements is I want to think about other ways to construct. So in the interest of showing you some of the fun tools that are embedded in this geometry environment, here's the thinking question, and I'd like you to put your ideas in the chat. How can you construct a trapezoid or an isosceles trapezoid using the transformation tools? Let's see what I'm talking about. The transformation tools are reflection, translation, rotation, and dilation. And I've skipped over the first one, symmetry, which is 180-degree rotation. So it's a specialized kind of rotation. So think for a minute and put in the chat what you might do to use one of these tools to construct a trapezoid or an isosceles trapezoid. Okay, I've got some ideas. On Cabri Junior, I am going to get myself a new screen to mess around with some of these constructions. And one common way to construct an isosceles trapezoid is with the reflection tool. So let's begin with a segment. And then I'm going to construct a line that is neither parallel nor perpendicular, neither parallel nor intersecting my segment, sorry. And we're going to use our reflection tool to reflect the segment over the line. The way the reflection tool works, you have to choose the line of reflection first and then choose the item to be reflected. So here's my line of reflection, and here is the object that I want to reflect. And I'm not going to complete it right now, but I think you can see that what I've got here is the outline, the skeleton, if you will, of an isosceles trapezoid, because as I move one endpoint, it's going to exactly mirror. So here are my congruent non-parallel sides. And when I connect them across, I will get the parallel sides. So that's an idea for reflection. Coming over to TI-Nspire, I want to share with you a couple of ideas. And the first one, again, I'm not necessarily going to instruct kids on how to do this, but I'm thinking back to my what if question with dynamic geometry. What if I let you use other tools? Can you come up with other ways to construct? And it really opens up the whole situation for students. So this time what I'm going to do is I'm going to begin with a triangle. And so think about what you might do if I gave you a triangle and said, construct for me a trapezoid. Now, again, my goal tonight was to show you some of the transformation tools, but there are other ways to use a triangle to create a trapezoid. What I want to do is first, I want to create the midpoint of one of my sides. Midpoint lives in my construction tools menu. And so there's a midpoint of one of my sides. And what I want to do now is I want to rotate this triangle 180 degrees around the midpoint. So I could plop down the number 180. I could rotate using that midpoint as the center of rotation with 180-degree rotation. But if you recall, in the transformation tools, that symmetry tool is 180-degree rotation. So the symmetry tool says, what do you want to rotate? What do you want to use? I want to start with my triangle, and I want to rotate it around this point. If you're doing this on Cabri Junior, the triangle will flash at you. Actually, let's just pop over here really quick. If I want to make a triangle, I'm just going to make it over here on the side. And when I make my triangle, if I clear out of the tool, just watch for a second what happens on Cabri Junior. First, the whole triangle flashes at me, then just the side flashes at me. And that's the communication within Cabri Junior. Which do you want to select? Over here on TI-Nspire, whoops, I accidentally put down another point. Here, when I put my cursor here, it just asks me triangle. It doesn't separate it out into sides. I could, of course, put a segment down on the sides. Let us over here get another item. I want to get a vector. And if I lay a vector along either of the sides of the triangle that I didn't use for the midpoint, my last transformation tool I'm going to share with you is the translate tool. I'm not the last one, I'm sorry, I've got one more. And what I'm going to do is I am going to translate the triangle by the vector. And there I have my trapezoid. Okay, I do have one more tool. I want to put a point down. And I want to put a segment down. And I need to put down the number 2. So I need a text box. Okay, and this last transformation tool I want to share with you is the dilation tool. And I want to dilate the segment with respect to the point using the number 2. And I think you can see I've got the skeleton of a trapezoid again. And you can explore what happens when you move the segments, when you move the point of dilation, and when you change the scale factor. Okay, the very last thing on trapezoids before we carry on is that there's some fun calculations that you can do. When you do a computation on the TI-Nspire, you have to pick the measurement tool out of the menu, and I want the length of the top segment. And my length tool here, you'll see it says polygon. What it's doing is it's offering me the perimeter of the whole polygon, but it says a little tab indicator. So if I press my tab button, either on my keyboard or on my calculator, it's going to toggle between the side, whoops, sorry. Okay, so that's the length of the side. I want to do the same thing for the bottom. That was a segment. So there's my segment down there. And what I want to do is I want to take a look at the mid segment of my trapezoid. And we don't have time to do this fully, but when I take a measurement, that measurement of that mid segment has some really interesting features of it. And so I can right click on that segment and take the measurement right from there. And so I would want students to play around with that. What do you notice? And hopefully students are going to notice that the mid segment is in between the distances, and maybe you'll see that there's an average going on here. And I like to develop this with students, and it really relates to the area formula for a trapezoid. So there's a lot more you can do with this. Back over on Cabri Jr., just before we leave this, if you want to do a measurement here, you, like before, you select the measurement tool that you want. And you have to wait whether you want just the side of this triangle or the whole triangle. And alternatively, you can click twice on the endpoints of this segment. There's a fuller exploration of various construction methods of trapezoids and more about that mid-segment property in your webinar documents. But let's shift gears and let's go over to circle segments. So on Cabri Jr., I'm going to open up a file that I've created for this. Okay, and here is the circle segments. And here it is over here on the Nspire. And these are 2 chords that are intersecting inside a circle. And what's interesting about this is that you probably have taught your students about the property of these 2 chords, that they get divided up proportionally. You can prove this with similar triangles if you want, but you might have taught it where then they learn a new topic when you have 2 secants that intersect a circle, or when you have a secant and a tangent. And so students end up having to memorize 3 different rules, or it seems to them to be 3 different rules. So what I've done is I've made one construction that captures all of this into one. And this really is in the service of reducing our cognitive load for our students. When I grab that center and pull it out, whoops, too far, I get my segments, my secants, excuse me. And so we can investigate the power of a point by taking a look at one construction. And what I've done on Cabri Junior is I've done all of the math for the students already, but I've hidden away these products. And I know that they're hidden. The way that Cabri Junior works with its hide and show, you don't know where things are hidden until you bump into them. So you choose the hide show tool, and I know I hid something there, so I can press enter to show it. And now drum roll, please. Let's see what happens over here. Whoops, and this is a little bit off because of the pixels on the screen. So let's get P to a place where our pixels and our measurement rounding looks a little bit more convincing. And there we go. Inside, I've got those measurements rounded off, and the products are equal. Coming over to TI-Nspire, I've got the same kind of a setup with some fancy colors, so we can see where our segments are and what the pieces are for students to multiply. By the way, in the webinar documents, there's another version of the Cabri Junior activity, which has 3 separate files that you can share off to student calculators. I've included this one that is all one construction because I really like having just one construction. The TI-Nspire version from the TI website was already one construction. And what I want you to see here is that we can, besides doing the computation right on the screen, which of course we can do, there's a setup on TI-Nspire where you can, you have to type your text and you have to tell it what you're going to do. So we're going to type A times B, and then I right click or I choose calculate out of the menu, and it's going to ask me what are the 2 things I want to multiply. So I want to multiply the 2 pieces of that chord, and I selected them. Now this text, this expression can be used to calculate again. So again, I asked to calculate, and now let me multiply the other 2. And there they are, same as the Cabri Junior on the 84. And as we move point P, we're going to get the different products. We can see if we can make point P right at the center. Not quite, can't quite get radii. When you come out here, you can also move point, I think we can move point C and get a tangent going on. So you can also see that this works for the tangent case. The last thing I want to show you before I pass it off to Steve is that the other power of the TI-Nspire is that you can capture data. So this is the same construction, but each one of my measurements I've now given a name to. And if you see they are bolded, when you have a number on your screen, let me just go back to this one here. If I click on this number on my screen, I can store it as a variable. Sorry. If I click on that number and then control store, it's going to allow me to give it a variable name. I'm going to escape out of it because I don't need it on this screen. But that's what I've done in this second problem. I've stored each of these numbers as variables. And they change as I drag and observe what's happening. Because again, we want students to drag and change their figures, see what happens. Does something hold true all the time? And now these 4 items can be captured. And here I've set up a lists and spreadsheets. And the capture command, you can either do it manually or you can do it automatically. The 0 here in the command indicates that it was manual. And the way to capture a point is you do control decimal point. It says capture in really small letters. And from the geometry screen, I can move point P to a new location and control capture. Move my point P to a new location and control capture. And let me get one more location and control capture. And let me try and get a tangent set up. Pretty good, not exact. Control capture. I don't have to go back to the spreadsheet each time I want to capture. But what you'll see here is if I carry on over, I had it set up to multiply those two products of the two parts of the line. And each time they are equal, and that's the power of the point. I looked up earlier tonight and I actually found an official definition of the power of the point. It's a relationship between a circle and a point anywhere in the same plane. If you create a line through a point P that intersects the circle in two places, that power of the point is going to be the product of those two segments. And that point will have the same power regardless of how many lines you send through it, which is why these proportions work. Okay, I want to send it over to Steve. The last thing is that if your geometry class spends a lot of time with proof, you can do proofs of these things. I find it more instructive to have students justify why they think it is true. And if you don't need to do a formal proof, you don't have to do a formal proof. We get kids talking about why it works. Anyway, on to you, Steve. I hope I left you enough time for all of your fun, amazing stuff.
Cool. Thanks, Karen. So, oh man, let's go to hit the wrong button. There you go. So let's go to, I'm going to do all of this stuff on the TI-Nspire. Love the TI-Nspire. And so most of this is going to be visual. Candy will talk about some things. If there are questions, drop them in the chat. I'm sure Karen will shout out, and if they need to be asked, they can ask them. You will be getting a copy of this in the show notes after the webinar. So, but I've made some changes of this because I had to send this to Mike 2 days ago. And so I had 2 days to change things. So if you want those, just reach out to me on social media and I will certainly get this your way. So a couple of things that you can do with this. Love the Nspire, the 3D geometry. This is my floating cube illusion. Now I can either click, like I'm on the software, I can click and kind of drag things around slowly. I could also click on the, page there, click there and do it as well. But I like doing this. So there's that floating cube, which I'm like, how does he do that? How does he do that? I don't know. So here's, now there's a couple of quick commands that you can do. So if I happen to click on O, it would orient this automatically to kind of the home screen. If I click on the A button, that's going to automatically rotate. So there is the secret of the floating cube. It's actually just 3 squares. Oh my gosh, there it goes. There it goes. So I'm going to press escape to stop it on the keypad or on your keyboard as well. But there is the floating cube. So that just still, like, I still can't unsee it, which is kind of weird. So here's the next one. This is like this doesn't work as well. I like it. I was messing around with this. This is kind of like eyes, but if you look at them, it'll appear that one of the eyes is bugging out and one of the eyes is bugging in, if that makes sense. So I don't know what's going to happen. Let's see. Oh. I don't know. So let's see. Yeah, I shared something like this in the Facebook group, I think. So let's see what happens. If we remember, what letter do we press to automatically rotate this thing around? Automatically begins with the letter A. So I'm going to click on A. And here is the secret behind it. I still, like, when I see this, I like can't unsee it, like right around like here, like, oh my gosh, what's happening? I really don't know. It's just kind of hard to see. And so here's another little optical illusion, this is the long tunnel. I don't know what's, oh, long tunnel. So where is the, if it's an illusion, where is the illusion? And so the illusion, what letter do we press to automatically rotate? A. So here it is. So really, this is kind of like, this would be a frustum of a pyramid, which is what I'm doing. The lines are under the attributes, and those are some of the things that you can change, but we'll do some other things with attributes later. But oh man, it's kind of hard to unsee that. I know, kind of hard to unsee that. So let's go to, I forget what's next. Here is one of my like favorite activities that I used to do with when I taught geometry. My I had like, it wasn't an honors geometry, but it was an advanced geometry class, and these kids were like a little advanced in algebra the year before, but they weren't quite advanced enough to be into like honors algebra 2. So this is one of the first things we did. Now you might be thinking, like, on the Nspire, where the heck is the 3D grapher? So I've got this blank screen and it says press menu. I'm going to press menu. Everything starts with the menu on the Nspire. And I'm going to insert a graph. I prefer to use the number pad, so I'm going to press 2 when I'm on my handheld. And this still doesn't help me much. So, but I'm on a graphing page. This doesn't look like 3D, but again, I'm going to go back to the menu and I'm going to see what happens. And so, ooh, this gives me some help. So the 3D graph is like a view, a graphing view. So I'm going to press 2. And sure enough, 3D graphing is 3, only appropriate. So I'll press 3 again. And so here is my 3D grapher. By default, it shows up in like a Cartesian equation. Z equals a function of X and Y. And what I like to do with this, what I did with my kids early on, they came to me with a pretty good understanding of slope intercept and the standard form of a line. And so this gives them something a little bit different to mess with, is let's look at cross section. So if I type in X plus Y and I just press enter, and then I can click on my keypad and turn it around, but I'm on a computer. So here is we could argue, looks like it's a regular hexagon, but do we know for sure it's a regular hexagon? So we could have that discussion very early on in a geometry course around geometry and vocabulary and this idea of establishing proof. So now, how do I get the entry line back? I typically do Control G. That's one way to do it. I'm sure there are other ways to do it. And you'll notice I'm now on Z2. I don't want to be on Z2. I want to go back to my Z1. So I'm just going to toggle up. And that's the only thing the kids really need to do. And so I wonder, I have no idea what's going to happen. What if I go 2X plus Y? Kind of nervous. I'm going to press enter. Not sure what's going to happen. But oh. So parallelogram? Or could it be something else? Could it be something more? And I'll do one more of this again. Great little activity, kids. I believe there are, it's either 11 or 13. It escapes me now, but different cross sections that you can make. And so again, I'm going to toggle up again. And so I'm curious about this, and I'm going to delete out the 2 times just for kicks. And I'm going to go to the end, and I'm just going to try. I don't know what's going to happen. I'm going to put in a +5. Let's just for kicks, we'll see what happens. This may or may not work. And oh, it did work. It did work an equilateral triangle. So those are some, that's what I used to do. Kind of the first early days in geometry, I got kids messing around with the TI-Nspires, messing around with the geometry app, messing around with the 3D geometry app. And these were kids, these were my, they were advanced algebra 1 kids. They weren't in honors algebra 1. They were just advanced algebra 1, but they were in advanced geometry class. So this gave them a kind of a chance to kind of look at slope, intercept, and lines. But now it was planes, something brand spanking new, but they always enjoyed this. So let's see where I am. Let's see where I am. Oh, wrong button. Let's see where I am here. Yes. Oh, a couple other things I'll share with you. You guys have probably seen this if you're in a Facebook group. So I'll press an A to automatically rotate this puppy, and I'll use this slider. So this is super powerful for a handheld. I don't think there's any other handheld that'll do this. So that is my net of a cube. If you I always had some really creative kids. If you can find a parametric equation for a surface, like on Math World or somewhere else, you can graph it on the Nspire. So this is just done in parametric mode. And if I toggle up, that's kind of what I did. But if you find the equation, you can graph it. So this is really, really powerful. And this is actually a really nice graph look. So let me go. This one, Heidi Rudolph, if you know Heidi. This bugged me, though. This really bugged me. She asked me, she said, hey, do the painted cube problem. So I go, okay, I'll do the painted cube problem. And I did not plan very well ahead, but here's my painted cube. So, when you paint the cube, how many cubes will have all the sides painted? How many will have 2 sides painted? How many 3? And so I can explode this and count it up. But there's a problem here. On the Nspire, there's only room for 99 3D functions. Unfortunately, there are 27 cubes, and each cube requires 6 functions to create. It requires a different function for each side. I'm trying to find a way to do that in one, but anyway, I ran out of function spaces to complete this. I'm still kind of working on some workarounds, but anyway, it's what it is. But that was for Heidi. So let's see. So, I don't know if there's anything else. I'm not going to do that one. Let's see. Again, Mobius strips. If you can find a parametric equation for a surface, you can graph it on the Nspire. So this is pretty cool. Don't like that one. That one's ugly. So that's 3D stuff. That's the 3D stuff. You might not think it's ugly. I just didn't care for it much. The more it's, I don't know. Is what it is. So let's go to 2D geometry quickly. Here's a couple of cool little features that we'll use to try to construct a conic. So I created this polygon using the polygon tool, and Karen shared that before. And I'm going to go back to my keypad. And so I can drag this around. Pretty cool. Drag it all around. I want to do some measurements. What I'd like to do is the area. So I'm going to go menu, because that's where I go if I want to figure out what to do. And area would be a measurement. That's number 6. So I'm going to go 6. And then area is number 2. I'm going to click on number 2. And then if I just hover, it selects the whole triangle. I click once to kind of get that area. And if I drag it up here, I can place that down. And whenever I'm done doing something, I want to press the escape key to put my tool away. So I'll press the escape key on the keyboard and put my tool away. Now, right now, that I can drag this puppy around everywhere. And what I'm really interested in is how can I drag this point so that the area does not change? And so if I hover over, and then if you control menu on that keyboard, you will end up getting, I kind of control menu to me is kind of like a right click. I get the sub menu. And what I'd like to do is I'd like the attributes of this measurement. And so the attributes will allow me to change the a number of decimals that are showing. But what I'm interested in is that little lock icon on the second one down. So if I toggle down one and toggle to the right one, the object is now locked, and I'll press enter, excuse me, to kind of make it stick. And now what I can do is I can grab that point, and the only way I am trying to drag it up and down, and I cannot drag it up and down. I can only drag it left and right. And so another cool feature, if I go, again, I click on there, if I control menu again on the point, one of my options is a geometry trace. And a geometry trace will kind of leave like a little trail behind when I drag that point around. So it kind of lets me know that it kind of looks parallel to the base. I think that's an important theorem in geometry, that if that vertex moves parallel to the base, the area is not going to change. So that is a feature in the Nspire, that this construction by constraints. I'm constraining this shape so that has a particular area. Let me press escape. And if I right click again, if I do that control, I'm yuck. I need to click on that and click it over here in a white space, an empty space, and it will give me an option to erase geometry trace. Now I'm going to, let me delete this. Let me delete this measurement for a second. I'm going to go ahead and delete it. That was also a control menu. And now this point is free. I am free. I am free. So we did the area. Let's measure the perimeter. So again, I'm going to control menu, and 8 is my measurement. Oh, I forgot to pick something up. I think I need to pick my triangle. Let me try that again. There's my triangle. It's blinking. Let me try this again. Menu. Then I'll go 6. And then I will go length, which is actually going to be the perimeter. I'm going to try that again. My computer is really stressing right now. So menu, 6, and then 1 for length. And will I get it? Will I get it? I don't think I will. Don't think I will, and that's okay. I'll go to the next one. We'll try to get on the next one. Try to get on the next one. Let's see. I'm not going to do this one. I do like this one. So here's one I did earlier. Again, we're going to lock measurements again. I have point A and point B, and point P is in between. Did not mean to do that for both of them. I did not mean to multi-select, but I can drag point P, and the measurement at the top of the screen on the left is the measurement from A to P, and the measurement on the right is the measurement from P to B. And so what I'm interested in is, if I were to take the ratio, that ratio right now is not quite 2 to 1, almost like 5 to 3. We could probably make it a little bit, maybe closer, 2 to 1. So what other points, like where could I place point P to kind of keep that kind of 2 to 1-ish ratio, or whatever that ratio is? So I'm going to go, I want to create a little text box, and I think Karen did this. And what I'm interested in is, I'm interested in taking this this ratio A to B, and I want to calculate this. Well, let me try that again. So accidentally hit delete. This is the problem when calculate is right next to delete. I do that more times than I care to admit. So I will calculate. So I want to select, I'll select a 10.9. And then I will go over and select the 5.25. And this gives me my ratio, not quite 2, and I'll place it down right there. And I want to lock that ratio, because right now, if it's not locked, this point can move freely. Well, that's what they said. That point can move freely. but I would like to know where else can that point be so that ratio stays constant. So I'm going to lock this, I'm going to lock the attribute, this measurement. So I'm going to right click on it, control menu, and I will go to attributes. And I'll toggle down to the lock, and then I'll toggle to the right to lock it, and I'll press enter on my keypad. And so now I've got this point, and that point can move around, but it can't move anywhere else. And it almost looks, it kind of maybe almost might look a little bit kind of a hyperbolish. I wonder what it is. Let's right click on the point and let's do the geometry trace and let's see what happens. So this is not a hyperbola. It's going to go off the screen. It's going to come back over here. This is actually an Apollonian circle. So whenever I look at points that are kind of the same distance, that's going to create a circle for me. I wonder if I could drag. I can't even. Oh, I can drag that. I wonder what will happen. I wonder what would happen. Oh, that point's just moving around P because it's locked. So let's use this to construct an ellipse, and this will probably end up being the last thing when I have time to do, it looks like. So let's use this to I'm not going to do Karen's problem. So here is the way we could use this tool to construct an ellipse. I'm going to go to my menu, and I'm going to go to points and lines, and I'm going to do a segment. I'm going to construct two segments. I'm going to construct a segment from here to here, and then from that point there, I click and drag, and I'll place the other point there. And after I'm done, I'm going to press escape to put my tool away. What I would like to do is I'd like to measure the lengths of the segments. So as I hover over the segment, I can right click, which is control menu. I can go to 8, which is measurement. I can grab its length, and that is this segment on the left. I can do the same thing, hover over the segment. Control menu is the TI-Nspire version of right clicking. I can choose 8 and then 1 for length, and that is that length. Oh, did not mean to click it like that. What I'd like to do is I'd like to add these two measurements together. So I'll right click in an empty space, and I will choose 5 for text, and I will go A plus B, because the definition of an ellipse is the sum of these two segments should remain constant. So I will right click on the text, and I will calculate, being careful not to hit the delete, and then I will select one measurement and select another, and I'll drop that puppy down. This happens every time. I don't know why. It always comes out to be 16 for me. I don't know why. So I'm going to hover over the 16, and then I'm going to do the right click, control menu. It brings up this sub menu, and I'm going to go to the attributes at the top, which is number 2. And we've seen this a couple times now. I'm going to toggle down on the keypad and toggle to the right to lock it and press enter to make it stick. And now I'm going to take that point. I'm going to right click on the point, and I'm going to geometry trace this puppy. And let's grab this point and see what happens. I have no idea what's going to happen. Let's see. Oh, so I'm trying to drag it up and down. This point is constrained in such a way that the sum of the lengths of the two segments is always constant, which is always 16. It has not changed. And so that gives me the construction of ellipse. If I just happened to change the plus to a minus, I don't know what's going to happen. I wonder if it would let me do that, but I'm kind of running out of time. But these are the things that I like to do on the Nspire, and that my kids kind of like to do on the Nspire. And it is a really nice. Yeah, I can't. I'd have to unlock everything to make that puppy work out. But you can do a lot of different things. This idea of constraining, like a construction by constraints, is actually quite old. And there was a guy that used to show up at the old TI conferences years ago who used to share stuff about that. But anyway, that is that for me. If you want to see this file, I know Mike's going to share the file with you. But again, like I said, I had 2 days to mess with it, Mike. So that means I made changes. But anyway, if you need this, just reach out to me on, like, I'm in the Facebook group, and I'm also around on Twitter, and I'll put my handle down there in the chat so you can reach out to me that way. But Karen, I'm going back to you.
I think
Or
you might
Mike.
be going
Is
back
it
to
Mike?
Mike.
Is it Mike? Okay, we're going back to Mike. That's two over that way.
Thanks so much, Steve and Karen. Well, kind of back to Karen for a second. Karen, do you want to talk about this Facebook community that people keep on referencing in the
Yes.
chat?
So I put the link in the chat. It's Facebook. Let me find it again. It is, here we go. It is facebook.com/groups/TI teachers. And it's a community of educators who are using TI technology, and you can ask questions and get lesson ideas and communicate with others. And there's a whole bunch of TI instructors on it too to help out when needed. So please join us. And Mike, can I share something else that I just want to share from the internet?
Yeah.
Okay, just real quick. I also wanted to share with you, because Mike doesn't have a screen for it, there's in just a few short weeks, there's a virtual T-Cubed conference, Saturday, September 30th. It's a free one-day virtual conference. So check out the education.ti.com website to check out the free virtual conference, September 30th. Back to you, Mike.
Awesome. Thank you. I'm going to actually put that link in the chat.
And while Mike's putting the link in the chat, I want you to know that in the webinar documents, there's some extra files. There's a previous webinar that I did that was called Geometry Grab Bag. So if you want some more pre-made files for your students, I put the link in the webinar documents. And that's one of the most powerful things is you can pre-construct some of these documents for your students, for the students who can't construct them themselves, and all of your students can access really powerful geometry.
Awesome. Thanks so much, Karen. As promised, we are giving away to one lucky winner a TI graphing calculator of their choice. And tonight's lucky winner is Reagan Davis. So Reagan, congratulations. I'll be reaching out to you here soon to get some information from you, but huge congrats on receiving our webinar drawing tonight. To receive a certificate of attendance, click the link in the chat window. Also listed is a link for the documents that we've been promising from Karen and Steve. And if these links aren't working for you for any reason, hang tight. You're automatically going to get a follow-up email in a couple days, and that will contain links to the certificate, the documents, as well as the recording, so you can watch this at your own pace. If you're watching this on demand, go ahead and copy that link into your favorite browser to receive your certificate. If you need to get a hold of us for any reason, give us a call or send us an email at 1-800-TI-CARES or ti-cares@ti.com. We always welcome your feedback and questions and comments. Speaking of feedback, when you leave the webinar tonight, your browser will automatically appear with a survey, and we really appreciate your thoughts. If there's things that you think we can do better, let us know. If there's things that you really loved, let us know. We really appreciate your thoughts and comments as we plan future online webinars. Huge thanks to Karen and Steve for everything they put together tonight. Thanks so much for everything, guys.
It's great to be here. Thank you, Mike.
And huge thanks to everyone for joining us tonight from all across the world. We hope to see everyone back online next week. Have a great night.